y, right? I have the y head. Then you will start to ask, where is y head? Y head is, after you estimate, you will get the y head, right? Y head is our estimate model. Y head is our estimate model. So the residual, I represent it as a u. U is a y minus the y head. Y minus the y head. So this is how we get the residual, right? So this is how we get the residual. So what is y? Your original series. For example, like this y point. Okay, this is my data point. This is my y. And then y head is after you estimate your model. So which consists of the independent variable. So for example, your y head will be like the, okay, in this case, my demand, right? My demand equals to beta 0 plus beta 1 y t plus the residual, okay? So after you estimate, this is the y head, right? This is my y head, the estimated model, the y head. So how you get your residual? Residual is a difference between the y and the y head. So this is the y head, right? This is the y head. Dependent head. After you estimate, you got the y head. So these are from your estimated model. So you got the y head. So the difference between your y and the y head is my residual. So the gap is on my residual. So my head is the residual. So how about residual sum of square? The residual sum of square is you square that you power 2 them, right? You power 2 for each of them. Then you sum them together. Sum from here to here. How to write this? Okay, if let's say here is 0.5, the gap up, okay? This is 0.4, 0.2, 0.7, 0.5. Then you sum them together. With power 2, right? You sum them together from here to here. Then this is the residual sum of square, RSS. This is the residual power 2. So this is the idea of how you get the residual sum of square. So you square them, right? You power residual, right? You use residual sum of square is how we get that. So means that OLS, actually the ordinary square is used to obtain the efficient parameter estimate by minimize the residual sum of square. So this is called OLS, right? The principle for this OLS. Actually, the method we're going to use in the simple equation, right? In the simple equation is called OLS. We can use the OS to estimate the bivariate model, multivariate model. Actually, based on what principle? This ordinary square is come up. We estimate the parameter estimate, which is the beta 0 and beta 1, by minimize the residual sum of square as small as possible. Why I want to do that? Because if we have the very huge variance, very huge standard error, will make our parameter estimate bias, right? So we want to minimize the residual sum of square as small as possible. Why? This is the data point, right? And this is my y head. This is my estimated mark. So this is my estimated, and this is the difference is my residual. And then my ambition is want to make this residual very small, the gap, right? The gap between the real and also the estimated is very small. Then only perfect, right? My model is perfect. If not, the model is not perfect, right? So, OS principle is want to minimize this residual sum of square as small as possible. That is the principle behind the ordinary square method. So now what is my difference? So that's why I come up with this residual sum of square, right? So the gradual consolidated idea is this is the test statistic based on the F-test. Actually, it's a kind of WALD test. WALD is a kind of WALD test. WALD. is actually the first step, you regress the y on all the leg y without the information x. Then obtain the residual sum of square. Then this is actually the restricted model. We call it as a restricted model. Then obtain the residual sum of square from the restricted model that I plot in here. Right? After that, rerun the equation with all the information, with the general model, with the information leg y and also leg x. So this is called unrestricted model. Unrestricted means you do not exclude out the x. So just this is called unrestricted model. Then after that, from this equation, obtain the residual sum of square, right? And then plug in here. Then from the general model, then what is n? What is n? And also what is n? And what is k? N, which has n, and n is the number of leg x term. Leg x term in the unrestricted model. How many n? How many leg in the unrestricted model? And then n is referred to the observation. How many observations you have? Sample size. Another way is called sample size. K is the number of parameter estimates. Number of parameter estimate in the general model. In the step number 2. How many number of parameter estimate means refer to how many number of coefficient. The slope coefficient in the step number 2. So, what is the hypothesis? The leg x do not belong in the regression. It means that the hypothesis is the x not greater cos the y. Under this condition, because you regress the y on the leg y, right? So in this condition, x not greater cos the y. So x not greater cos the y. If your test statistic exceed the critical value, this follow the F distribution, right? This no longer T. This follow the F distribution. So follow the F distribution, right? So here is the rejection region. So if your computed F greater than the critical value, so you fall in the rejection region. So you reject the H now. If you reject the H now, means what? So it means that your x is belong to the y, right? The H now is the x do not belong. So if you reject, it means that you have the potential that your x is belong, right? Your x is belong to the. It means that your x is greater cos. Is greater cos the y. So this is the greater causality idea. So you also can run whether the y is greater cos the x. So if you want to test another way, whether the y is greater cos the x, then you have to switch the x with the y with the x, right? So you rerun the x on all the leg x, then obtain the residual sum of square, right? And then you rerun the x on the y and the x. This unrestricted. Just turn around the variables. So in that case, you will have a 4 possible outcome. So these are the 4 possible outcomes. Either y greater cos the x, or y or x greater cos the y. It means unidirection, only one way. One way causality from the x to the y, or from the y to the x, or they have a bilateral causality that causing each other, or they are not causing each other. So they may have a 4 different possibilities in this case. Right? Either they not cause each other, or you cause me, I cause you, or we are causing each other. Right? So there are 4 possible possibilities here. So for other like greater causality discussion, you can refer to the link, right? To the link to see the discussion on how people apply the causality. So you can click, cannot download, maybe you can copy and then paste them. Causality. So this is the classical papers published in 1996, published in the Journal of Development Economics. I also got share this journal in the Spectrum. It's talking about the financial development and also economic growth. So this classical theory in the economic growth, either is financial development lead economic growth, or economic growth lead the financial development. Right. These are something like the widely researched topic and also published a lot in the past two decades. So this paper is a highly cited paper, and they focus on the time series evidence from the 16 countries, including our discussion today, like talking about the causality. So, but we apply in a different way. We use the example my demand and also the my demand also income. But they focus on the whether finance lead the growth or growth lead the finance. This is another something like the classical theory in the economic growth and finance. Yeah. So now, this is the model presentation like what we discussed just now. The models. In this one, I want to see whether M greater cost of GDP or GDP greater cost of M, right? Yeah. So there are 4 possible outcomes, like what we say just now. 4 possible. Either M greater cost GDP or GDP greater cost of M, or they are not crossing each other, or they are crossing each other. So there are 4 possible outcomes. If they have the crossing each other, we call it as a feedback causality. Feedback. You cause me and cause you. Feedback, right? You beat me, I beat you, right? Like the children now today, right? You beat me, I beat you. That's a feedback. Or they call it as a bilateral causality. Bilateral. So this is a conventional term that they use in this causality field, and called feedback or bilateral causality. Independence means no relationship. So I ask you one question now. Is it possible that in this regression, why significant on the my demand? Why significant in the my demand but no causality? Is it possible? If I run the regression, my beta 1, means the coefficient for beta 1 actually significant on the my demand.